This video is on chapter 4 part 3. There were a few parts to the notes that we did not complete. So in question 1F, this was the question that we left. Okay, we were supposed to estimate the solutions to this equation over here. At the moment, we already have the graph, the parabola for y equals to x squared minus x minus 2, and it looks like this. So how are we supposed to use our graph to determine solutions for x squared minus x minus 2 equals to 5? First, we need to notice whether there are any similarities or not. So you see that x squared minus x minus 2, it appears in both of them. So keeping in mind that we already have the graph of y equals to x squared minus x minus 2, we are supposed to use our graph in a way to determine the solution to this equation. So how do we go about doing it? First, let's recap on some of our basics. When we had straight line graphs, for example, this is a graph of y equals to maybe x plus 3. So this is our y-intercept of 3. So we have a graph already. And if the question says, use your graph to solve x plus 3 equals to maybe 1. How are you going to do it? Well, we all know that the solution is easy. X equals to 1 minus 3, which is simply negative 2. But how are we going to use our graph to solve this? So since I already have the graph of y equals to x plus 3 and it appeared twice, okay, make constant comparison with our actual question in chapter 4 part 3. We have a graph already. We are supposed to use the graph to solve an equation where there are similarities between the new equation and the current graph that we have. So in this case, we equate this portion to be y, because this is the graph that we already have. So y equals to x plus 3, that is one of it. So on the other side, this must also be equal to y. Okay, so one way to write all these is that y is equals to x plus 3, which is at the same time equals to 1. Okay, so this means that we need to plot the graph of y equals to 1 and find intersection between y equals to x plus 3, which is already drawn for us, and the graph of y equals to 1. Once we find the intersection points, then x coordinate of intersection is solution. Okay, so this is what it's going to look like in this case. This is 3 over here, and this is 2 and 1. So here I've got a line y equals to 1. The point of intersection is over here. So if this graph is drawn to scale, this value, when I read off the graph, it should show me that x is equals to negative 2 based on the graph. Okay, another way to look at it is that suppose you are told to solve y equals to x plus 3 and y equals to 1 simultaneously. So you will let this be equation number 1, we let this be equation number 2. Solving equation 1 and 2 together, sub 2 into 1. Therefore, we will end up with 1 equals to x plus 3. Isn't this the same equation as this over here? So you need to constantly remind yourself that solving simultaneous equation is just the same as plotting the two equations, the graphs of the two equations, and finding the intersection point. So if we were to solve it simultaneously, we will get x equals to -2. If we do it graphically, we will plot, if we solve this simultaneous equation graphically, we will plot y equals to x plus 3 and y equals to 1, and we find the point of intersection. This will have a value of x equals to -2, which is exactly what we are trying to do here. Okay, so bringing all these back to our quadratic equation, since I already have the graph of y equals to x squared minus x minus 2, all you need to do is put over here y equals to. So now, to solve, so this is what is going through my mind. To solve x squared minus x minus 2 equals to 5 with the graph, I need intersection point of y equals to x squared minus x minus 2 and the graph of y equals to 5. And we already have the graph of y equals to x squared minus x minus 2. It is easy to now plot the graph of y equals to 5 because it is just a straight horizontal line. So in our graph, we include the line y equals to 5 as shown over here. The points of intersection of this line y equals to 5 as well as the quadratic curve, the parabola, will give us our value for x. So in this case, there are two intersection points, one over here and one over here. Okay, let's take a look at the question again. The range for x is from -3 to 3. Okay, so we do not need to be bothered with this particular point of intersection because our graph ends here. If the graph were to continue, we will get another solution, but we are told that, hey, the graph is only valid for x from -3 to 3. Therefore, we only have one solution in this case, and this value over here is -2.2. So this is for part F. In your graph, label part F, and this is our answer. So at the back of your graph paper, you write, this is the presentation that you can have. X squared minus x minus 2 equals to 5. This is the original equation. So you just write, draw y equals to 5. So this is one of the presentation that you can have. Okay, we already have this graph, y equals to x squared minus x minus 2. So just draw y equals to 5. From the graphs, the intersection point has an x coordinate of -2.2. Okay, so in order to check our answer, we can try substituting it back into our original equation. Okay, so this is our original equation. When x equals to -2.2, left hand side equals to -2.2, and we square it minus -2.2 minus 2. So let's evaluate this. So on the left hand side, it is evaluated to give us 5.04, which is quite close to the right hand side. So therefore we know that, hey, our answer should be quite accurate. Okay, while it doesn't give us the exact value of 5, we see this and we can conclude that, yeah, our process is correct. The error over here, why we didn't get exactly 5.00, could be due to inaccuracy of the graph. It could also be due to the scale used, because it is not precise enough. So this is the approach for this type of questions. So the next similar type of question is over here. Okay, this is on page 8 of your notes. Right, so we see that an example to solve x squared minus 5x plus 6 equals to 0, one way to do it is by factorization, if it can be factorized. So we get x minus 3 times x minus 2 equals to 0, and therefore we get the two values of x, which is 2 and 3. So another way to solve this same equation is to do it graphically by drawing a quadratic graph. However, drawing a graph requires at least two variables, x and y. We cannot draw a graph of x squared minus 5x plus 6 equals to 0 because you don't get a table of values. So the graph that we will be drawing will be y equals to x squared minus 5x plus 6. So by plotting the values, we are able to get a parabola that looks like this. So this is our parabola with the equation y equals to x squared minus 5x plus 6. But this parabola doesn't help us solve the original equation, which is x squared minus 5x plus 6 equals to 0. And that is where the same concept of simultaneous equation comes in. Consider solving simultaneously the equations y equals to x squared minus 5x plus 6 and y equals to 0. If you are told to solve these two simultaneously, you will call this equation number 1, you will call this equation number 2, you will substitute equation 2 into equation 1 and arrive at x squared minus 5x plus 6 equals to 0. And from here, you will factorize and get two values of x. This is solving with substitution, but another way of solving equation 1 and 2 simultaneously is by using the graphical method, which means that we need to plot the graph of y equals to x squared minus 5x plus 6 y equals to x squared minus 5x plus 6, as well as the other equation, which is y equals to 0. In red, this is my graph of y equals to 0. And the points of intersection will give us the solutions. So in this case, for this particular question, we will have the values of x as 2 or 3. Okay, so this will have a value of 2, whereas this will have a value of 3, obviously not drawn to scale. So if we were to do it over here, we have x minus 2, x minus 3, and we get the same values of x, 2 and 3. So with this in mind, how then do we use our existing parabola to solve the equation x squared minus 5x plus 6 equals to 0? So all we needed to do was, using the graph of y equals to x squared minus 5x plus 6, say that we draw the graph of y equals to 0. If you remember the presentation from the earlier question, it goes something like this: x squared minus 5x plus 6 equals to 0, and we draw a bracket. We say that this is y. We already have this graph. Then we just need to copy down equals to 0, whatever is on the right hand side. In this case, it is equal to 0. So we just need to draw y equals to 0. The intersection point will be our solution. So after I draw the y equals to 0 line, which happens to be the x-axis, this gives me the two values, the two intersection points, 2 and 3. Okay, as explained over here. So the two solutions from the graph, the two solutions are x equals to 2 and x equals to 3. So these are known as the two solutions or two roots of the quadratic equation. Remember, we mentioned that the word root is the same as solution. Okay, so next part, we need to use the graph, the same graph of y equals to x squared minus 5x plus 6 to solve the following equations graphically. So we follow the same template. Note that we already have in our mind, we have graph of y equals to x squared minus 5x plus 6. Okay, so keep this in mind, and we are going to use it. So the first question says, solve x squared minus 5x plus 6 equals to 2. And we see that these are the same. So the presentation, very simple, just draw a bracket. This is equal to y. Keep in mind we already have it. Copy down whatever is on the right hand side after the equal and write the word draw. So draw the graph of y equals to 2, find the points of intersection. So from this, we draw the line of y equals to 2. This is my line, y equals to 2. There are 2 points of intersection with the parabola. This has a value of 1. We are only interested in the x value. This will be 4. So the two solutions are 1 and 4. Okay, so we can call it solutions, we call it the roots. Next question, part B. Solve by using a graph x squared minus 5x plus 6 equals to 6. Okay, same thing. We notice that, hey, these parts highlighted are the same. So we take our pencil or pen, bracket it out, write down that this is the same as y. Whatever is on the right hand side, copy down and write the word draw. So draw the graph y equals to 6. Back to the graph. When y equals to 6, this is what we have over here. This is a graph of y equals to 6. It intersects the parabola at one point over here and another point. So this value, this x value is 0, while the other is 5. Therefore, the two solutions are 0 and 5. Next question, still similar, and we still see that we have the same x squared minus 5x plus 6. But this time, on the right hand side, is x plus 1. Don't worry, do use the same steps. So on the left hand side, this is equal to y. On the right hand side, we just need to copy everything down. Okay, so x plus 1 equals to, write the word draw. This time, it is no longer a horizontal line. This time, we have to draw a graph of y equals to x plus 1, which we all know is a straight line sloping upwards with the y-intercept at 1. So draw the straight line y equals to x plus 1, find the point of intersection. So here we have the diagonal line, y equals to x plus 1. So as mentioned, it intersects at 1 over here. And we have to find the point of intersection of this straight line with the parabola. So here is one intersection, here's another intersection. This is a value 1, and this is a value 5. Therefore, solving this, graphically, we read off the values. The roots are 1 and 5. And now for the final question, exercise 3. You have already drawn your graph as part of your homework a few days back. You have already answered from part A to part D. Now we're going to attempt part E using the graph to determine the solutions of following equations. So if you look at the graph that we currently have, on the right hand side we've got 2x squared minus 5x minus 3. In E, part 1, we've got the same, 2x squared minus 5x minus 3. Part 2, also the same. Part 3, also, oh no, not the same this time. Okay, so let's work with part 1 and part 2 first. This tells me that, part 1, I copy down the equation. So 2x squared minus 5x minus 3 equals to 0. This is what they want me to solve. So I draw a bracket. And I say that, hey, I already got a graph, this graph, y equals to 2x squared minus 5x minus 3. as shown over here. It's a parabola. Then I just need to copy down all these equals to 0. Write down the word draw. So by drawing the graph of y equals to 0, which we all know is the x-axis, we are able to find the points of intersection, and the x coordinates of these points of intersection will be my solution or roots to E part 1. So now for E part 2, we've got 2x squared minus 5x minus 3 is negative 3 over 2. Same thing, write down this is equal to y, and I already have the graph. Copy everything else down, equals to negative 3 over 2. So write draw. This again is a horizontal line. Determine where it is, find the points of intersection. Now the interesting one is part 3. Okay, we've got 2x squared minus 5x minus 7. Minus 7, and this is equal to 0. Well, I'm very tempted to write down that this is equal to y, but do I have this graph? Do I have the graph of y equals to 2x squared minus 5x minus 7? I don't. I only have the graph of y equals to 2x squared minus 5x minus 3. So now my objective is to manipulate this such that it looks like this. So quite clearly, 2x squared and 2x squared are the same. Okay, let's do it term by term. 2x squared, same. Negative 5x, same. Now I've got a negative 3 over here, but I don't have a negative 3. If only the negative 7 is a negative 3, that makes my job a lot easier. Is there a way to do it? So there is. 2x squared minus 5x, I want the negative 7 to become a negative 3. And I do that by adding 4 to the left hand side. So from negative 7 it becomes negative 3. But I cannot just add a 4 on the left hand side without changing the right hand side. So on the right hand side I also must add 4. So now I have 2x squared minus 5x minus 3 equals to 4. And I see that, hey, this is my left hand side. This is the graph that I currently have. Y equals to 2x squared minus 5x minus 3. So the same process takes place, equals to 4, and I write the word draw. Again, this is a horizontal line. From here, find the points of intersection, find the solutions. For the rest of the lesson, please check that you have completed your homework and your corrections.